Good evening. Uh, so let's start our live introduction session for week 12 for course Biomechanics by Professor Varadhan, Department of Applied Mechanics and Biomedical Engineering, IIT Madras. I am your TA, Manjunathan, a research scholar from the Department of Applied Mechanics, IIT Madras. So I hope you have watched videos for our week 12 of the course. So in week 12 of the course, in week 12 of the course, the some of the contents from that is spillover from week 11, that is uh, till complex numbers and quaternions were discussed in week 11. Moving forward with the same thing, the singularity, Gimbal log, parameterization of such uh, composite uh, measurement of orientation has been continued to week 12, and also with the practical application how these orientation can be measured in actual uh, ways or an experimental system. Such details has been discussed, and also a brief discussion about stability and gait analysis. So these are the contents that is being covered majorly in week 12. So hope you have gone through the videos. So let's move to the interactive question section. So I'll be reading out the questions and give some time for you to think and answer the questions. Please do try to attempt the questions. Uh, don't worry, even if you are going wrong. Uh, if you are going wrong, you will remember. So please try to attempt the questions and try to inbox the answers. So here is our first question for today's session. Question is, a kinematic singularity occurs when, or when does a kinematic singularity occurs? That's the first question. Options are: option A, determinant of Jacobian is 0. Option B, when the velocity is maximum. Option C, the orientation matrix is an identity matrix. Option D, acceleration is 0. So which among the following is the answer for kinematic singularity? Try to answer the questions. Oh, when will a kinematic singularity occurs? Options are: option A, when the determinant of the Jacobian is 0. Option B, when velocity is maximum. Option C, when the orientation matrix is an identity matrix. Option D, when acceleration is 0. Yes, correct option is option A, when determinant of the Jacobian is 0. Option A is the correct answer. When determinant of the matrix, Jacobian matrix becomes 0, then a Jacobian loses a rank. That's what known as singularity. So option A, determinant of Jacobian is 0. That's the correct answer. Next question. Gimbal lock in Euler angles leads to which among the following? Options are: option A, increased degree of freedom. Option B, loss of one rotational degrees of freedom. Option C, infinite solutions. Option D, no rotation. When is a gimbal lock occurs in oil triangles? Or what's the effect of gimbal lock in oil triangles? Options are option A, it increases degree of freedom. Option B, loss of one rotational degree of freedom. Option C, infinite solutions. Option D, no rotation. Correct answer is option B, loss of one rotational degree of freedom. In gimbal lock in oil triangles means that two of the oil triangles aligns each other. So when two of the oil triangles aligns or become parallel to each other, then it essentially loses one rotational degree of uh, freedom. So that's something called gimbal lock. Correct answer is option B. Two axes or two orientations, two axis rotations align with each other, causing the loss of one independent rotation. Next question. Which representation avoids singularity completely? Options are option A, oil triangles. Option B, rotational matrices. Option C, quaternions. Option D, axis angle. So these are four representations for the orientation of something in an 3D space. So which among the following representation can avoid singularity completely? Options are option A, oil triangles. Option B, rotation matrices. Option C, quaternions. Option D, axis angle. Correct answer is option C, quaternions. Quaternion representation can completely avoid the singularity. It can avoid both gimbal lock and singularity. In quaternions, the representation is like a vector plus, sorry, a scalar plus a vector. So this is the vector part, this is the scalar part. So this is how quaternion has four uh, components. So this extra additional detail can help to avoid singularity and gimbal lock. Next question. A drawback or disadvantage of rotation matrices is. Options are option A, singularities. Option B, redundancy. Option C, unique non-uniqueness. Option D, limited range. Which of the following is a disadvantage of rotation matrices? Option A, singularity. Option B, redundancy. Option C, non-uniqueness. Option D, limited range. Correct answer is option B, redundancy. This is the correct answer. The drawback of rotation matrices is redundancy. Why? Because we need a lot of elements to fix. So rotation matrices is something like a 3 by 3 matrix. For a 3D rotation, we need a 3 by 3 rotation matrix. So, like for x-axis, rotation about x-axis is 0, 1, 0, 0, 0, 0. Here we have sine, cos, cosine. These components will be there. So for expressing rotation about one axis, we need 9 elements. Uh, so this makes redundant. So when we have for other this is rotation about x, then rotation about y, z, all this becomes a lot of angular components that complicate the process. So it's like redundancy is the main issue with the rotation matrices. Next question. Euler angles are preferred when? Options are option A, avoiding singularities. Option B, computational efficiency is needed. Option C, human interpretability is required. Option D, high accuracy is required. When are the Euler angles preferred? Options are option A, to avoiding singularities. Option B, when computational efficiency is needed. Option C, when human interpretability is required. Option D, when high accuracy is required. Correct answer is option C, when human interpretability is required. Euler angles requires human interpretability because Euler angles are defined as which rod and yaw. So these kind of terminologies needs human interpretability to understand uh, what is the protection types. So for physical interpretation, human element is required in the case of Euler angles. Next question. Select all the true statements in regard of full hand kinematics measurement system designed in using IMUs. Options are: option A, the master and slave arrangement was required to achieve a data update of 100 Hz. Option B, BNO 055 was programmed to provide output in the form of quaternions. Option C, the IMU based HKMS is accurate than the optical trackers and the electromagnetic tracking sensors. Option D, the HKMS device used just 12 sensors to compute the kinematics of the full hand. So here the question is, select all the true statements in regard of the full hand kinematics measurement system. This is HKMS, full hand kinematics measurement system designed in using IMUs. Options are: option A, the master and slave arrangement was required to achieve a data update rate of 100 Hz. Option B, the BNO 055 was programmed to provide output in the form of quaternions. Option C, the IMU based HKMS is accurate than the optical trackers and electromagnetic tracking sensors. Option D, the HKMS device used just 12 sensors to compute the kinematics of the full hand. Correct answer is option. Correct answer is A, B, and D. These three. A, B, and D are the correct statements. Next question. A dash is the time interval between two consecutive occurrence of any one of the repetitive events of walking. Options are: option A, stride; option B, swing phase; option C, pace; option D, gait cycle. Dash is the time interval between two consecutive occurrence of any one of the repetitive events of walking. Options are: option A, stride; option B, swing phase; Option C, pace. Option D, gate cycle. The correct answer is option D, gate cycle. Answer is option D, gate cycle. So the time interval between two successive occurrence of any one of the repetitive events of walking is known as gait cycle. A gait cycle is one full repetition between two identical events in walking. Next question. Which of the following are considered when analyzing stability in gait? Options are option A, center of mass over feet. Option B, torque by each foot. Option C, knee ligament strength. Option D, cadence. Which of the following are considered when analyzing the stability in gait? Options are option A, center of mass over feet. Option B, torque by each foot. Option C, knee ligament strength. Option D, cadence. Question can have multiple option answers. So while you are attempting the exam, also try to select more than one questions. If the question is allowing more than one options, that you can check. Yes, options A and B. These are the correct statements. Center of mass over feet and torque by each foot are considered when analyzing the stability in gait. Because stability depends on the balance and force distribution, not ligament strength or cadence. Next question. The dash diagram is a representation of ground reaction force vectors at regular intervals of a walking cycle. Options are option A, Venn diagram, option B, free body diagram, option C, butterfly diagram, option D, network diagram. Correct answer is option. Correct answer is option C. Butterfly diagram option. C. In gait analysis, it is not free body diagram, it is uh, butterfly diagram. Here, at an average, gait cycle is mostly represented using something known as a butterfly diagram. So, the it gets a name from the representation. Like, so this is x and y axis. Then first representation will something like so something some. This will be the uh, vectors of ground reaction force. So from the shape, it is known as butterfly diagram. Option C is the correct answer. Free body diagram is mostly we using statistics. I mean statics, not statistics. Statics. Next question. If the pressure on feet during standing is 10 Newton per centimeter square, the peak forces during walking can reach up to dash Newton per centimeter square. Options are 10, option B 15, option C 30, option D 60. If pressure on feet during standing is 10 Newton per centimeter square, the peak forces during walking can reach up to what level? Options are option A 10, option B 15, option C 13, option D 60. The correct answer is option C, that is 30, because it can reach up to, mostly it is at like 2 to 3 times of the force of the standing pressure. The correct answer is 30 Newton per centimeter square. Walking increase the pressure by around 2 to 3 times of the standing value. So 30 Newton per centimeter square. So here the conceptual clarity is needed. Next question. Match the following times. Terms are here, some terms and their meanings have been given. So try to match it. First one, terms are heel strike, toe off, swing face, mid stance. Meanings are beginning of gait cycle, foot leaves the ground. Option C, leg in air moving forward, body weight over stance limb. Try to match the following and inbox the answers. You can inbox like what's the uh, this side only A B C D that thing. What will match what you can give first, then match what will be the match of two, like that in order you can put in the message. These terms are actually corrected correct only. Heel strike is the beginning of the gate cycle. I mean initial contact when the uh, when someone put the foots down, that portion is known as a heel strike. First, the heel is touching the ground, so it's a first of the gate cycle. Then toe off is the time where foot leaves the ground, and swing phase is the phase where leg is in the air, and mid stance is the third uh, step in the gate cycle where the body weight comes one body in one leg is in air and body weight comes over the stance limb. Whichever limb is on ground, the body weight is transferred to that limb. That is a mid stance. So it is correctly matched only. Next question. The stride length is the distance between two successive placements of the same foot. Options are option A, true, option B, false. The next true or false question, whether the given statement is true or false. The stride length is the distance between two successive placement of the same foot. Correct. The given statement is true. The stride length is the distance between two successive placement of the same foot. Next question. Which of the following ligaments is not a part of the knee stabilization? Which of the following ligaments is or are not the part of the knee stabilization? Options are option A, medial collateral ligament, option B, lateral collateral ligament, option C, posterior cruciate ligament, option D, ulnar collateral ligament. Which ligament is not a part of knee stabilization? Options are option A, medial collateral, option B, lateral collateral, option C, posterior cruciate, option D, ulnar collateral. No, only D only is the correct answer. Ulnar. This, if you remember, ulnar. Where is the bone? Ulnar bone. So it's in hand and elbow. So ulnar collateral ligament is in elbow, whereas the other three is a part of knee stabilization. UCL belongs to elbow and not the knee. Posterior cruciate, middle collateral and lateral collateral belongs to knee stabilization. Next question. What does the swing phase signify in the gait cycle? Options are: option A, foot is flat on the ground. Option B, leg moves forward in the air. Option C, heel touches the ground. Option D, foot leaves the ground. Which one of the following gives the meaning for swing phase in gait cycle? Options are: option A, foot is flat on the ground. Option B, leg moves forward in the air. Option C, heel touches the ground. Option D, foot leaves the ground. We have just see the we have saw the meaning of the phases, these phrases in our previous question, maths following question itself. If you can recall that, you can easily answer the question. Is correct. If you simply, this word itself is intuitive. Option B, leg moves forward in the air. That is the swing phase. Swing phase is also the non-weight bearing forward motion. Next question. Which phases are part of the stance phase in the gait cycle? Options are: foot flat. Option B, toe off. Option C, terminal stance. Option D, initial swing. Which phases are part of the stance phase in the gait cycle? Options are: foot flat. Option B, toe off. Option C, terminal stance. Option D, initial swing. The question can have multiple answers. The question is, which phases are part of stance phase in the gait cycle? A to C. That is foot flat, toe off, and terminal stance. These three as part of stance phase, whereas initial swing is a part of swing phase. So foot flat is the second. First was the heel strike, then foot flat, mid stance. All of these were in the stance phase, whereas pre-swing and initial swing are in swing phase. So A, B, and C, three options are the answers. Next question. The relative joint angle between two finger segment is computed using which among the following? Options are addition of the quaternions. Option B, difference of Euler angles. Option C, inverse parent into or multiplied by child quaternion. Option D, dot product. The relative joint angle between two finger segment is computed using which among the following? Options are option A, addition of quaternions. Option B, difference of Euler angles. Option C, inverse parent multiplied by child quaternion. Option D, dot product. Now the correct answer is option C, that is inverse parent into child quaternion. That is inverse of parent quaternion multiplied by child quaternion. That gives the relative joint angle between two finger segments. Correct answer is option C. Next question. IMUs measure which correctly, or which of the following components can be measured by IMU? Options are option A, position. Option B, orientation. Option C, acceleration and angular velocity. Option D, force. Which among the following can IMU measure directly? Options are option A, position. Option B, orientation. Option C, acceleration and angular velocity. Option D, force. The correct answer is option C, acceleration and angular velocity. From the given options, this is the correct answer. IMUs can measure acceleration and angular velocity. IMU or commercial measurement unit. This can measure linear acceleration using an accelerometer, and this rotation rate or angular velocity using gyroscope. Plus, additionally, it can uh, measure magnetic field. If it is in a magnetic field, then it can measure the magnetic field using the magnetometer. These are the things that IMUs can measure directly. Next question. Drift in IMU based systems is mainly due to which among the following? Options are option A, sensor noise, option B, numerical errors, option C, integration of angular velocity, option D, calibration. The correct answer is option C, integration of angular velocity. So this accumulation of small persistent errors in the gyroscope uh, and the accelerometer may lead to the drift in measurements over the time. So the correct answer is option C, integration of extra velocity or accumulation of errors in the gyroscope. Next question. The flexion extension in finger joints occurs about which axis? Options are option A, longitudinal axis, transverse axis, option C, vertical axis, option D, arbitrary axis. Flexion and extension in finger joints occurs about which axis? Options are option A, longitudinal axis, option B, transverse axis, option C, vertical axis, option D, arbitrary axis. answer is option B, transverse axis. So this for this kind of questions, you have to remember the general anatomical positions. With that, you try to answer the question. Correct answer is transverse axis. Uh, if you remember the anatomical position, so uh, you can understand this transverse axis. It will pass through the centers of MCP-IP joint, that is metacarpophalangeal and interphalangeal joint. Through here will the coronal axis passes or the transverse axis will pass. So the correct answer is transverse axis. Next question. In HKMS, the sensor fusion is required to which among the following? Options are option A, increasing the sampling rate. Option B, reducing the drift and improve orientation accuracy. Option C, reduce number of sensors. Option D, measure force. In HKMS, sensor fusion is required for what? Options are option A, increase sampling rate. Option B, reduce drift and improve orientation accuracy. Option C, reduce number of sensors. Option D, measure force. Correct answer is option B, reduce drift and improve orientation accuracy. Fusion combines sensors to improve accuracy and reduce shift. Correct answer is B. Next question. The master-slave architecture in HKMS helps in which among the following? Options are option A, increasing battery life. Option B, parallel computation. Option C, synchronizing multiple IMUs. Synchronizing multiple IMUs. Option D, reducing noise. The master-slave architecture in HKMS helps in which of the following? Options are option A, increasing battery life. Option B, parallel computation. Option C, synchronizing multiple IMUs. Option D, reducing noise. Correct answer is option C, synchronizing multiple IMUs. Option C is the correct answer because this will ensure synchronized data acquisition across the sensors. Next question. A major limitation of IMU based HKMS is options are option A high cost, option B line of sight requirement, option C magnetic interference, option D large setup space. Which among the following is a major limitation of IMU based HKMS? Options are option A high cost, option B line of sight requirement, option C magnetic interference, option D large setup space. Correct answer is option C, that is magnetic interference. In the previous question, I have mentioned that IMU has a magnetometer also. So this magnetometer can pick up magnetic disturbances which can affect the accuracy, and it can limit the usage and also measurements. So option C, magnetic interference due to the magnetometers in the IMUs. Next question. The number of degrees of freedom in full hand kinematics is approximately option A 6, option B 10, option C 20 plus, option D 50 plus. The number of degree of joints in full hand kinematics is approximately option A 6, option B 10, option C 20 plus, option D 50 plus. No, it's wrong. Correct answer is option C 20 plus. This is the correct answer. The number of degrees of freedom in full hand kinematics is approximately 20 plus. Because it total there are actually 33 DOFs in the hand rest system, but often 20 to 27 is the range that we use to do the calculation for a full hand HKMS. Next question. During calibration, sensors are aligned to which among the following? Options are option A, global coordinate system, option B, local segment coordinate system, option C, gravity vector only, option D, arbitrary frame. During calibration, the sensors are aligned to which among the following? Options are option A, global coordinate system, option B, local segment coordinate system, option C, gravity vector, option D, arbitrary frame. Yes, correct answer. Option B, that is local segment coordinate system. During the calibration, the sensors are mapped to the segment's anatomical frame. That is the local coordinate system. So the correct answer is option B, local segment coordinate system. Next question. A static calibration pose is primarily used to which of the following? Options are option A, measure velocity, option B, define reference orientation, option C, reduce noise, option D, increase sampling rate. A static calibration pose is primarily used to which among the following? Options are option A, measure velocity, option B, define reference orientation, option C, reduce noise, option D, increase sampling rate. Yes, correct answer. Option B, define reference orientation. The static calibration pose is primarily used to define the reference orientation, mostly used to establish the baseline orientation reference. Next question. Dynamic calibration helps in which among the following? Options are option A, sensor placement, option B, estimating joint access, option C, battery optimization, option D, data storage. Dynamic calibration helps in which among the following? Options are sensor placement, option B, estimating joint access, option C, battery optimization, Option D, data storage. Correct answer is option B, estimating joint axis. So dynamic calibration means the movement based calibration. So that is required or that is helpful in estimating the functional joint axis. Next question, double support phase occurs when or when does double support phase occurs? Options are option A, both feet are off the ground. Option B, one foot is in swing phase. Option C, both feet are on the ground. Option D, only heel touches the ground. Correct answer is option C. So it's pretty intuitive because the word double support, you are getting both two supports. So two supports are uh, only achievable when both feet are on the ground. Option C, both feet are on the ground. Next question, running differs from walking by what? Options are option A, presence of double support. Option B, presence of flight phase. Option C, lower ground reaction force. Option D, slower cadence. How does running differs from walking? The correct answer is option B. Running differs from walking by the presence of a flight phase. Running has a flight phase that is not there in walking. Flight phase is the phase where there is no ground contact. Next question. Cadence is defined as which among the following? Options are step length, option B steps per minute, option C speed of walking, option D stride duration. Cadence is defined as option A step length, option B steps per minute, option C speed of walking, option D stride duration. Correct answer is option B steps per minute. Cadence is the steps per minute or number of steps per unit time is known as cadence. Number of steps per unit time. Next question. In normal gate, the maximum GRF or ground reaction force occurs during when? Option A initial contact, option B mid stance, option C push off, option D swing phase. In normal gate, when does the maximum GRF occurs? Options are option A initial contact, option B mid stance, option C push off, option D mid stance. Wrong answer. Correct answer is option C push off. Correct answer is option C push off is the phase where maximum GRF occurs. Next question is DIP joint has 2 degrees of freedom. It's a true or false question. The DIP joint has 2 degrees of freedom. Option A true, option B false. Correct answer. The DIP has only 1 degree of freedom, that is flexion or extension. It's a hinge joint. DIP is distal interphalangeal joint. Interphalangeal joint is a hinge joint with only 1 degree of freedom. So the statement is false. Next question. In the figure shown, Q wrist, Q prox, Q mid, and Q dist indicates the quaternion values obtained from the sensors placed on the wrist, proximal segment, middle segment, and distal segment of the finger respectively. Which of the following operation is used in order to obtain the relative quaternion of the DIP joint? In the figure shown, Q wrist, Q prox, Q mid, and Q dist indicates the quaternion values obtained from the sensors placed on the wrist, proximal segment, middle segment, and distal segment of the finger respectively. Which of the following operation is used in order to obtain relative quaternion of the DIP joint? Options are option A, Q dip relative is equal to quaternion wrist conjugate into Q mid. Option B, Q dip relative is equal to Q mid conjugate into Q dist. Option C, Q dip relative is equal to Q dist conjugate cross Q mid. Option D, Q dip relative is equal to Q prox conjugate cross Q mid. Correct. Option B is the correct answer. So from here itself, we can find the components. Q dip is here, so it should be between these two. So even if you don't have the idea, then can easily from the figure itself you can eliminate the options. So rest is not there. Also prox is not there. So only two option trust and also relative option from qmit occurs before qdist. So this is the correct order. Option B. The same question we have discussed as a conceptual question earlier. Q deflative is equal to Q mid conjugate cross Q dist because the relative rotation is represented as inverse of the parent quaternion cross child quaternion. Next question. The IMU used in HKMS is options are IMU 20, option B LSM 6DS3, option C Pulse 40 IMU, option D BNM 055. Which among the following is the IMU used in the HKMS? Options are option A IMU 20, option B LSM 6DS3, option C Pulse 40 IMU, option D BN0055. The correct option is option D. We have already uh, discussed. BN0055. This is the correct answer. Next question. Select the correct statements for HKMS validation. Options are option A. HKMS was experimentally validated using a typing task. Option B. Different hand postures and object graphs were used for experimental validation of HKMS. Option C. The HKMS was validated by static and dynamic calibration against highly precise electromagnetic tracking sensors. Option D. A data globe was used to calibrate the HKMS. Choose the correct statements for HKMS validation. There can be more than one answers. Options are option A. HKMS was experimentally validated using a typing task. Option B. Different hand postures and object grasps were used for experimental validation of HKMS. Option C. The HKMS was validated by static and dynamic calibration against highly precise electromagnetic tracking sensors. Option D. Data glove was used to calibrate HKMS. The correct answer is statements A, B, and C. Correct answer is options A, B, and C. Except from option D, all are used for the val calibration of all are used in HKMS. Next question: how many microcontrollers were used in HKMS? Options are 1, P4, C5, D6. How many microcontrollers were used in HKMS? Options are option A 1, option B 4, option C 5, option D 6. Correct answer is option C 5. So for the master slave architecture, here the study used 5 microcontrollers. Correct answer is option 5. Next question: which method gives the highest spatial accuracy in lab conditions? Options are option A IMU, option B optical tracking, option C magnetometer, option D gyroscope. Which method gives the highest spatial accuracy in lab conditions? Options are option A IMU, option B optical tracking, option C magnetometer, option D gyroscope. Correct answer is option B, that is optical tracking. So optical tracking gives the highest spatial accuracy in lab conditions. Next question. A 2D rotation matrix must satisfy which among the following? Options are option A, determinant is equal to 0. Option B, determinant is equal to 1. Option C, determinant is equal to minus 1. Option D, trace is equal to 0. Which among the following be a necessary condition for 2D rotation matrix? Options are option A, determinant is equal to 0. Option B, determinant is equal to 1. Option C, determinant is equal to minus 1. Option D, trace. No, wrong answer. Correct answer is option B. The determinant should be 1. So if you remember, these are cos and sine terms. So when taking the determinants, it will become cos square plus sine square theta, and cos square theta plus sine square theta is equal to 1. So for a 2D rotation matrix, the necessary condition is determinant should be 1. Next question. Which property ensures no scaling in rotation matrices? Options are option A, orthogonality. Option B, symmetry. Option C, skew symmetry. Option D, trace. Which property ensures no scaling in rotation matrices? Correct answer, option A, orthogonality. Orthogonality is the property of rotation matrices which preserves the vector lengths. That is, it preserves the vector lengths. It won't allow the scaling. Next question. The inverse of a rotation matrix is what? Inverse of a rotation matrix is option A, negative. Option B, transpose. Option C, determinant. Option D, identity. What is the inverse of a rotation matrix? transpose, C. Determinant, D. Identity. That's correct answer. B. Transpose. Next question. Which of the following is not true about rotation matrices? Option A. Columns are orthonormal. Option B. Determinant is 1. Option C. Commutative multiplication. Option D. Reserve vector magnitude. No, wrong answer. Correct answer is option C. That is commutative multiplication. This is the correct answer. We have already discussed these three just in the previous questions. These all are true for rotation matrices. The question is asking not true for rotation matrices. So commutative multiplication of is not possible. Suppose you have two rotation matrices Rx and Ry. Then Rx, Ry, if you multiply in this order, Rx into Ry is not equal to Ry into Rx. So the order matters. So the results you will get from Rx multiplied into Ry and Ry multiplying Rx will be different because in matrix multiplication row by column multiplication is being done. So when doing that you will get two different matrices. So you have to follow the order and rotation matrices multiplication is not commutative. Next question. In 2D rotation by theta is given by which of the following? Options are option A cos theta sin theta cos theta. Option B cos theta sin theta cos theta. Option C sin theta cos theta sin theta. Option D identity matrix. So this you have to understand like it's a 2 by 2 matrix. Cos theta sin theta minus sin theta cos theta. So this semicolon separates between the rows. So which of the following is a 2D rotation matrix by theta? correct answer is option B, that is cos theta minus sin theta. Sin theta cos theta. This is the correct answer. Option B. So that's all for today. Thank you for joining the section. So this is our last session for this course. Thank you all for joining.